October 18th, 2007. Japan announces its grand return to the skies. After 40 years of silence, the nation famous for building the world's most advanced cars and electronics reveals a plan to conquer aviation. The Mitsubishi Space Jet. A sleek, next-generation regional airliner designed to crush competitors like Bombardier and Embraer with 20% better fuel efficiency. The excitement was palpable. All Nippon Airways placed the first order. Airlines in the United States lined up for hundreds of jets. The Japanese government poured billions into the project, calling it a matter of national pride. But 15 years later, the dream ended in a scrapyard in Washington state. After burning through $8 billion, more money than it cost to develop the original Boeing 747, Mitsubishi had delivered exactly 0 aircraft. Not one. The prototypes were torn apart by excavators, and thousands of engineers were fired. How is this possible? Mitsubishi is not an amateur. They build the wings for the Boeing Dreamliner. They build fighter jets. They are a titan of global aerospace. So how did a company with decades of engineering experience build a plane so flawed that it was literally illegal to fly in the United States? And why did they refuse to fix it until it was too late? To understand how Japan's legendary engineering culture produced such a spectacular failure, we need to go back to the beginning. Back to a time when Mitsubishi believed they could conquer an industry they had never truly understood. The story begins not in 2008 when Mitsubishi launched the program, but in 1974 when Japan quietly abandoned commercial aviation altogether. That year, the NAMCYS-11 rolled off the production line for the final time. It was a 60-seat turboprop, Japan's first and only domestically produced commercial airliner since World War II. 182 were built. It was a capable aircraft, but commercially it was a disaster. Poor international sales, unfavorable currency exchange rates, and administrative chaos had drained government coffers. When production ended, Japan's aerospace industry retreated. For the next 3 decades, Japanese companies would build components for Boeing and McDonnell Douglas. They would become world-class suppliers, but they would never again attempt to build a complete commercial aircraft. Then came the 2000s, and Japan's industrial ambition reawakened. The Japanese government saw a gap in the market. Regional jets carrying 70 to 90 passengers were booming. Bombardier of Canada and Embraer of Brazil dominated the space with their CRJ and E jet families. But these aircraft were getting old. Airlines wanted something newer, more efficient, more comfortable. In 2003, the Japanese Ministry of Economy, Trade and Industry initiated a 5-year research program. They invested $420 million to study what it would take to build a world-class regional jet. The project landed at Mitsubishi Heavy Industries, and by 2007 they had a concept. The Mitsubishi regional jet would be revolutionary. Not just competitive with Embraer and Bombardier, but better in every measurable way. Here is where understanding aircraft certification becomes critical to our story. Building a commercial aircraft is not like building a car or even a fighter jet. Every single component, every wire, every bracket, every piece of software must be individually certified by aviation authorities. The Federal Aviation Administration in the United States, the European Union Aviation Safety Agency in Europe, and Japan's Civil Aviation Bureau all have slightly different requirements. This process typically takes thousands of engineers working for years. Boeing and Airbus have permanent teams of several hundred people whose only job is managing certification paperwork. They have built institutional knowledge over decades about exactly what regulators want to see. Here is the key insight that Mitsubishi missed entirely. Being a Tier 1 supplier to Boeing gives you experience manufacturing to specifications that someone else created. It does not teach you how to create those specifications yourself. It does not teach you how to navigate regulatory frameworks. It does not teach you how to integrate tens of thousands of components into a coherent system. Mitsubishi had spent 40 years building wings and fuselage sections to Boeing's exact requirements. They had mastered the art of following instructions. They had never learned how to write the instructions themselves. And yet, in March 2008, Mitsubishi formally launched the MRJ program with an order from All Nippon Airways for 25 aircraft. They promised first delivery in 2013. They projected total development costs of $1.275 billion. Both numbers would prove catastrophically optimistic. The first warning signs emerged almost immediately. Mitsubishi was the launch customer for Pratt & Whitney's new PW1200G geared turbofan engine, a derivative of the PW1000G family. This engine promised 12% better fuel efficiency than conventional designs. It was perfect for Mitsubishi's marketing pitch, but being a launch customer for an engine means waiting while someone else figures out their problems. Pratt & Whitney's certification timeline slipped. In early 2013, they announced the engine would not be ready until late 2014. The MRJ's first flight, originally planned for late 2013, was pushed to 2015. This was annoying, but manageable. The real crisis was brewing inside Mitsubishi's engineering department. Japanese engineers approached the MRJ the way they approached everything, with obsessive attention to detail and an insistence on doing things the Japanese way. They wanted every component optimized. They wanted every system elegant. They built an aircraft that was, by many accounts, an engineering marvel. What they did not build was an aircraft that met FAA certification standards. In late 2016, as flight testing progressed at Moses Lake, Washington, regulators discovered a fundamental problem. The aircraft's avionics bay and wiring did not meet FAA requirements for redundancy and separation. To understand why this matters, consider what happens when a wire fails in flight. Regulations require that critical systems have backup wiring routed through physically separate paths. If a fire damages one wire bundle, another bundle in a different location must be able to keep the aircraft flying. Mitsubishi's engineers had optimized for weight and manufacturing efficiency. They had not optimized for FAA certification. The wiring revelation triggered a complete redesign. This was not a matter of moving a few components. The avionics bay is the aircraft's central nervous system. Rewiring it meant redesigning structural elements, rerouting hydraulics, revising software, and revalidating the entire system. In January 2017, Mitsubishi announced a 2-year delay. First delivery would now be mid-2020, 7 years later than originally promised. The flight test program was extended from 2,500 to 3,000 hours. 1 or 2 additional prototype aircraft would be needed. Industry analysts began to calculate the true cost. Each year of delay added roughly $1 billion to the program. Suppliers were getting nervous. Airlines were getting impatient. But something more insidious was also happening. While Mitsubishi struggled with certification, American pilot unions were quietly erecting a barrier that would prove impossible to cross. To understand the scope clause, you need to understand how American regional aviation works. Major airlines like United, Delta, and American do not directly operate most of their regional flights. Instead, they contract with separate regional carriers like SkyWest, Republic, and Mesa. These regional airlines operate under the major carrier's brand, but their pilots work for the regional company at substantially lower wages. Understandably, mainline pilots do not like this arrangement. They have watched as routes they used to fly get handed to lower-paid regional crews. In response, their unions negotiated scope clauses into their contracts. These clauses limit the size of aircraft that regional carriers can operate. The specific numbers are 76 passengers and 86,000 pounds maximum takeoff weight. Any aircraft larger or heavier must be flown by higher-paid mainline pilots. The limit is contractual, not negotiable on a whim. These numbers were not arbitrary. They were designed to cap regional flying at the size of existing aircraft, like the Bombardier CRJ700 and the Embraer E175. Both of these jets squeeze in right under the limits. Here is where Mitsubishi made their fatal miscalculation. The MRJ-90, their primary variant designed to compete with the E-175, had a maximum takeoff weight of 94,000 pounds. That is 8,000 pounds over the scope clause limit. Mitsubishi had designed an aircraft that US regional airlines were contractually prohibited from operating. The scope clause problem was not entirely Mitsubishi's fault. When they designed the MRJ in the mid-2000s, many industry experts expected scope clauses to be relaxed. The rules had been loosened before. Why would they not be loosened again? But the pilot unions held firm. After years of watching their work outsourced, they were not giving an inch. Contract negotiations in 2012 locked in the 76-seat and £86,000 limits at American, Delta and United. Subsequent negotiations kept them frozen. Mitsubishi's primary American customers, SkyWest and Trans-States, had placed conditional orders for nearly 300 aircraft. But those orders were conditioned on scope clause relief that was never going to come. In 2019, Mitsubishi attempted a pivot. They rebranded the entire program as the SpaceJet and introduced the M100, a redesigned variant specifically targeting scope clause compliance. The M100 would be slightly smaller than the MRJ-90, with a lighter wing and a maximum takeoff weight of exactly 86,000 pounds. The redesign brought them interest. Mesa Airlines signed a memorandum of understanding. Industry sources suggested that nearly 500 letters of intent were circulating from major carriers, but none of these converted to firm orders. The reason was simple. After 15 years and $8 billion, no one believed Mitsubishi could actually deliver. Then came 2020, and the final blow. The COVID-19 pandemic devastated global aviation. Airlines parked thousands of aircraft. Orders for new jets collapsed. The regional jet market, already struggling, entered freefall. For Mitsubishi, the pandemic provided a face-saving excuse to do what they should have done years earlier. In May 2020, they halved the SpaceJet budget. They closed all international offices. Flight testing was moved entirely back to Japan. The Moses Lake facility was shut down. What they did not do was formally cancel the program. Instead, Mitsubishi entered a peculiar state of corporate limbo. They called it a pause. They said they would evaluate market conditions. They maintained that certification remained possible. Behind the scenes, the Western team that had been brought in to save the program understood the truth. Led by executives recruited from Bombardier, Embraer, and Boeing, this team had recognized years earlier that the MRJ-90 was fundamentally uncertifiable. They had pushed to abandon it entirely and redirect all resources to the M100. Mitsubishi's Japanese leadership refused. According to industry insiders, this was about face. Admitting that the MRJ-90, the original vision, was a failure, was culturally unacceptable. So they continued pouring resources into an aircraft that could never be sold in its largest potential market. In April 2021, Mitsubishi Aircraft Corporation laid off 95% of its remaining staff. The budget, once 370 billion yen, was cut to just 20 billion yen per year, barely enough to maintain documentation. A year later, the third prototype was quietly dismantled at Moses Lake. Japanese media barely covered it. On February 7, 2023, Mitsubishi finally admitted what the industry had known for years. The SpaceJet was dead. CEO Seiji Izumisawa told reporters that Mitsubishi had been naive about the complexity of aircraft certification. They had not anticipated how long development would take. They could not find the business case to justify continued investment. What he did not say was perhaps more revealing. Mitsubishi never obtained type certification from any regulatory authority. Not the FAA, not EASA, not even Japan's own JCAB. After 15 years and $8 billion, the SpaceJet remained legally unfit to carry passengers anywhere in the world. The wreckage of the SpaceJet program offers brutal lessons about the gap between manufacturing excellence and systems integration. Mitsubishi Heavy Industries remains a world-class aerospace supplier. Their Boeing 787 wing boxes continue to ship, and their military aircraft programs continue to advance. But the institutional knowledge required to design, certify, and support a commercial aircraft from scratch proved beyond their reach. Compare this to Embraer, which spent decades building institutional knowledge about certification before launching the E175. Or Bombardier, which evolved through regional turboprops before attempting jets. These companies understood that commercial aviation is not primarily an engineering challenge. It is a regulatory and integration challenge wrapped in engineering. Mitsubishi approached the MRJ as engineers solving technical problems. They optimized for performance, for fuel efficiency, for passenger comfort. What they forgot was that none of that matters if you cannot get certified to fly. There is an old saying in aviation: there are old pilots and bold pilots, but no old, bold pilots. Mitsubishi was bold. They believed that Japanese engineering excellence could overcome institutional inexperience. They believed that their track record as a supplier translated to capability as a manufacturer. They were wrong. Today, the regional jet market that Mitsubishi hoped to conquer remains dominated by Embraer. The Brazilian manufacturer's E175 continues rolling off production lines, selling to the very American carriers that rejected the spacejet. Bombardier has exited commercial aviation entirely, but not before selling their CRJ program to Mitsubishi for $550 million, in a final irony. One spacejet prototype survives. The 10th and final aircraft built will be displayed at the Aichi Museum of Flight, a monument to ambition and failure. The display plaque will note that the spacejet was supposed to mark Japan's return to commercial aviation 60 years after the YS-11. Instead, it marks something else entirely: the largest financial loss in regional aviation history, and a cautionary tale about the difference between building components and building aircraft. Mitsubishi's engineers created something remarkable in a technical sense. They just created something that could never legally fly. Perhaps the most haunting detail is this. Had Mitsubishi abandoned the MRJ-90 in 2017 and focused entirely on the M100, they might have had a scope-compliant, certifiable aircraft flying by 2020. The pandemic would still have hurt them, but they would have had a product. Instead, they chose pride over pragmatism, face over function. And $8 billion later, they had nothing to show for it but a museum piece and a lesson the aviation industry will study for decades. Some failures are tragic. The SpaceJet failure was entirely preventable.